Good morning, students. Chapter quadrilaterals exercise 8.2, that is sum number 4. In this sum, ABCD is a trapezium. In case of trapezium, AB is parallel to CD and BD is a diagonal. E is the midpoint of AD. Now, here we have to prove that one F is the midpoint of BC. So this one is the construction part. That means a line is drawn through E parallel to AB or CD, which intersecting BC at F and BD at G. Now see, given ABCD is a trapezoid. AB parallel to CD and BD is the diagonal E is the midpoint of AD. So this one is given in the question. To prove F is the midpoint of BC. So you have to prove that F is the midpoint of BC. Now, construction. Line is drawn through E parallel AB, which intersecting BC at F and BD at G. So this line intersecting BC at F and BD at G. Now prove in triangle DAB, in this triangle DAB, E is the midpoint of AD and EG is parallel to AB. This line is parallel of AB. Therefore, G is the midpoint of BD by converse of midpoint theorem. By converse of midpoint theorem, as EG parallel to AB, E is the midpoint of AD, therefore G is also the midpoint of BD. Again, in triangle BCD, G is the midpoint of BD. G is the midpoint of BD, and this one GA parallel to CD. So this line, that is GA, is parallel to CD in this triangle, that is BCD. Therefore, A is the midpoint of BC. So as G is the midpoint of BD, therefore F is the midpoint of BC. That is also by converge of midpoint theorem, and this you have to prove. So write here, proved. Sum number 5. In this question, ABCD is a parallelogram. E and F are the midpoints of AB and CD. BD is a diagonal. This BD is intersected by AF and EC at P and Q. Now we have to prove that one line segment AF and EC dissected BD. That means these two line segments divide BD into 3 equal parts. Now given A, B, C, D is a parallelogram, E and F are the midpoints of AB and CD. BD is the diagonal, well, BD is a diagonal, and this BD is intersected by that line segment AA and AC. Intersected by AA and EC at P and Q. So these two lines intersect BD at P and Q points. Now to prove AF and EC trisect BD, or DP equal to PQ equal to QD. That means trisect means divide into three equal parts. These three equal parts are DP, PQ and QB. Now prove AB parallel to, this AB is parallel to CD, and AB is equal to CD, as ABCD is a parallelogram. In case of parallelogram, opposite sides are equal and parallel. So result is opposite sides of parallelogram therefore AE parallel to FC and AE is equal to FC. AB parallel to CD and AE is part of AB, as AE is the midpoint of AB, so half of this one is also parallel of half of CD, because F is the midpoint of CD. Therefore AE parallel to FC and AE is equal to FC. Therefore AEFC is a parallelogram. Opposite sides are parallel and equal, therefore this becomes a parallelogram. Therefore AA parallel to AC EQ, this EQ parts is the parallel of AP and AP, this one parallel to QC. Now in triangle DQC, in this triangle DQC, A is the midpoint of DC, and this side AP parallel to this AP is parallel to QC. So P is the midpoint of DQ. F is the midpoint of CD. FP is parallel to CQ. Therefore, P is the midpoint of DQ. So this one, the reason by converge of midpoint theorem. So this one by converge, write that one, Roman 1. Next, as we taken that triangle DQC, now you take the triangle ABB. In this triangle, E is the midpoint of E is the midpoint of AB, and EQ parallel to AP. This EQ is parallel to AP. So Q is the midpoint. This Q is the midpoint of BP. That is also the reason by converge of midpoint theorem. Take that one, Roman 2. So from P is the midpoint. P midpoint of DQ. So here DP is equal to PQ and PQ is equal to QB. So first DP equal to PQ and second PQ equal to QB. So therefore DP is equal to PQ equal to QB. So DP equal to PQ equal to PQB. DP is equal to PQ equal to QB, or hence AA and this one EC trisect BD. As you got that part, so write here proved.